Hi everyone, welcome back to my channel. Today I brought the topic factorization. Before we start factorization, let me ask you a question. What is a factor? Do you know it? The numbers which can divide a given number exactly without remainder are known as factors. So what does it mean? For example, if I give it a 24, look at the 24 here, right? 24 can be divided by these numbers without remainder. If 24 is divided by 1, there is no remainder. If 24 is divided by 2, there will be no remainder at all, right? So when some numbers divide 24 exactly without remainder, then they are known as a factor. So here 1, 2, 3, 4, 6, 8, 12, and 24 are the factors of 24. In algebra, the algebraic expression which can divide a given expression exactly without remainder are known as the factors. For example, here you can see factors of a square minus b square are a plus b and a minus b. That means a plus b will divide a square minus b square exactly without remainder. A minus b can also divide a square minus b square exactly without remainder, which you must have divided in the junior classes, right? So here, the factors of a square minus b square are a plus b times a minus b, right? Now, what is a factorization? Remember, factorization is a process to split the given numbers or the expression into the factors. So here we can say like that. The process of splitting the given expression into its factors is known as a factorization. Okay, let me give you an example like this. 24. See, 24 has been splitted into the 4 and 6. 4 times 6 gives you the 24. So 4 and 6 are the factors of the 24, right? And here we can even say that, 8 times 3. 8 times 3 also gives the 24. So 8 and 3 are also the factors of 24. So when we split the given number into the different factors, then that process is known as a factorization. Okay, but in algebra there are different rules to factorize. So let's discuss about these rules. Okay, the first rule is take common in all the terms of the given expression. When I use the word common means, remember, it is the similar terms or the similar variable in the given expressions. Okay, let's get example here. Look at this one. If you look into the four terms here, in each term, you can see A is a common, or you can say that A is similar in each term. So our intention is just to take the common, means we are taking that similar term out of that expression, okay? Now, when I take the common as A, remember, we have to take the lowest power of the A, okay? A square means A times A. From A times A, we have to take one A out of that term, right? So when I take the A as a common, then what will remain? See, A plus B plus C plus D. Do you know how it remains like that? See, when I take the A common, then from the first term, there's the A times A. So one A is taken out, so there is one A remain, right? From the second term, what happened? There is AB. So I'm taking A out, that means B only remain. From the third term, A is taken out and the C remain. And from the fourth term, there is A is taken out and D remains. So it will become A plus B plus C plus D, right? Simply remember, taking common means you are taking that term or the variable out of that expression. Okay, let's take another example. Look at this expression here. Here, aq square plus 3a square x plus 4a x to the power 4. First, look at that. In each term, what is the common or what is the similar? So you can see here a and x, right? So when you take the a and x as a common, remember, you have to take the lowest power. So compare in each term, the power of a and power of x. When you compare, then the power of a will become the a to the power 1, right? And the x also have a lowest power as x to the power 1. So what is the common? Ax is a common. So when I take the x common, then the remaining factor remain like that. See, from the first term, when I take the x common from the first term, okay, there's a cube. So a is taken out, so there's only a square remain. From x square, there's x is taken out, so the only x remain, right? Then it will become a square x in the first term. What about the second term? Look at in the second term. In the second term, 3 remain there, right? From the a square, a is taken out, so only a remain, and x is already taken out, so there is no x. So in the second term, there is only 3a. What about the third term? There's a 4 remain, a is taken out, so there is no x. From the x to the power 4, x cube remain. Then the remaining factor becomes now a square x plus 3a plus 4x cube, since x is a common. Okay, this is the way how we take the common. Okay, take common in all the terms. You have to look always the common in all when you begin the factorization. Okay, now let's talk about the next rule here. So this is the next rule. Take common in a group. When I say the group may be the pair, group may be the group of the 3 terms or the 4 terms, like that. Okay, now let's get example here. Look at this here. Here are the four terms. Before you start factorization, first of all, always look for the common in all the terms. Do you see? Is there any common in all? Definitely not. There is not a common in all. There is no variable which is common in all the terms, right? Closely look at that. So in this situation, what will you do? Okay, here we can just simply take this one. See, this is the one pair. We can make a group, and this is another pair, another group. If you make a two different pair here, what will happen? Closely look at that. See, from the first pair or the first and the second term. So what is the common? The similar. That is definitely x. So it means that you are taking x as a common. So let's take this x out of that expression, right? So when I take so, then what will happen? Look at this. Then we'll get something like that. X is a common, then what is the remaining? Y plus Z. In the second pair or the second group, look at there, second and the fourth, third and the fourth term, right? A is the common, and what is the remaining? If you take A out of that term, out of that expression, then Y plus Z will remain, okay? And here, you can see here, look at this, clear carefully. This is Y plus Z in the first term and another Y plus Z in the second term. So this is also common. So it means that you are taking this term out of that expressions, okay? Then what will happen when I take this out of that? That will be Y plus Z is common. When I take this out, then what will remain? X plus A, okay? Now we have taken the common in a group, okay? Now let's get another example here. Look at this. Here, x square minus bracket a square plus b square xy plus b square y square. Before we proceed, look at there. There's a bracket part here. So let's first just open this bracket before we deal with the common, okay? So how can we open it? A square x square minus, multiply by the minus and xy. It will be a square xy. And then plus will become minus because minus plus will minus and b square xy. And then plus b square y square. Okay, now we have a four terms here. Now before we start, let me check. Okay, is there common in all? There is no common in all. Closely look at that. There is no common in all. So in that situation, what we need to do? We have to make again the group. Okay, we have to make a group here. And when you look at this first group here, this is two terms and this is another two terms. So let's make a group like this. Okay, from the first pair, look at there. What is common? Let's look closely. A and x is a common. If you look at the a as the lowest power, there's in the first term a square and the second term also a square. So we can take a square as a common. What about the x? If you look at the compare the power of x, then x to the power 1 is the lowest power. So from here, okay, then what will you get as a common from the first pair? A square is a common, okay, a square x is a common. Then what is the remaining? There's x minus y. What about the second pair? There's a b square y is a common. Let's look closely. B square and the y is a common. Then what will remain? X minus y. Okay. When you look at this one, don't forget here. When you look at here, you can see this part here. This x minus y and x minus y is once again is a common. Okay. So now we can take x minus y as a common. So let's take this as a common. So what will you get here? When I take x minus y common, just remove it from that expression. Then what remain? A square x minus b square y, which is the remaining factor. Okay, so this rule is known as the take common in a group. So when the common in all is not possible, then we just form a group and we take the common. Okay, now here what can we do next? Let's see the next example. Okay, now, the next rule, we are talking about the next rule. So this is very, very important rule. Look at this one. Using different forms as a square minus b square, a cube plus b cube, and a cube minus b cube. Okay. Before we start, we have to understand about this thing. What is a square minus b square? So that is a plus b times a minus b. You know that, right? So what is a cube plus b cube? That is a plus b times a square minus ab plus b square. And what is a cube minus b cube? That is a minus b times a square plus ab plus b square. So I will suggest you to memorize these all the forms. These are the very, very important formulas. So you need to memorize them. Okay. So let's begin with the first one, a square minus b square. Let's get example. 121 minus 25z square. Doesn't matter what happened. Whenever you start any factorization, simply understand you have to take the common. Okay. Without common, do not start it. Now, let me ask you the question. Is there any common? There is no common at all, right? So if there's no common, then at least there's a square. So can we make like this? 121 is the 11 square, and 5z whole square gives you the 25z square. We can just keep in this form, right? So if I consider this 11 as a and 5z as a b, what will happen? It will become a square minus b square. And you can look at there, compare with a square minus b square. We can apply a plus b times a minus b. Then what will happen? What will you get? It is 11 plus 5z and 11 minus 5z. 11 plus 5z, a plus b, 11 minus 5z, a minus b. Okay, using that way. Okay, let's get another one. See, look at this. This is the same formula, a square minus b square. We'll get another example. 50ax square minus 32aq. We have to factorize this. Again, I'm reminding you, before you start, always look for the common. Okay, look for the common. So can you tell me what is the common here? If you look at the number 50 and 32, what is the greatest number that can divide both of the number? So that is the common. So 2 is the number. 2 can divide both the numbers, right? And here, if you look in the variable here, a is the only common. And when you compare in the first term and the second term, what is the lowest power of the a? That is 1. So 2a will be the common. So let's take the common 2a. When I take the 2a common, what will remain? From the first term, it's a 25. 2 times 25 gives you the 50. So it's a 25. From here, a is taken out common, so x square remain. What about the second term, 16? 2 times 16 gives you the 32, right? And from aq, that is a square remain. Now, this is in the form of a square minus b square. So we can do like this. 2a times 5x whole square gives you the 25x square. 4a whole square gives you the 16a square. So it is in the form of a square minus b square, right? So let's consider this as a, and this, let's consider this as a b. Okay, and compare with a square minus b square. Then we'll be getting 2a times 5x plus 4a, 5x minus 4a. 5x plus 4a means a plus b. 5x minus 4a means a minus b. Okay. Okay, let's get another example. Look at this closely. You can even use here a plus b whole square and a minus b whole square, but we are factorizing. So let's not do that. Let's not expand it. Instead, let's consider this as a and this as a b. Now, again, you can compare with a square minus b square. It will become now a square minus b square, right? So when we apply the formula, then it will be something like that. 3x plus 2 plus 2x minus 3. Here, 3x plus 2 is a plus 2x minus 3 is a b. So it is a plus b in the first bracket. Look at the second bracket. It is a 3x plus 2 as a minus 2x minus 3 as a b. Since there's a minus, I'm keeping the bracket in each term, right? Okay, we got the two factors. Now, let's simplify this. 3x plus 2, let's open the bracket. 3x plus 2 plus 2x minus 3. Since there's a plus, no change in the sign. But in the second bracket, look at there. 3x plus 2 minus 2x. Now, it minus 3 becomes plus 3. Why? Because minus is outside and we are multiplying by the minus. Okay. And now here, 3x plus 2x gives you the 5x and 2 minus 3 gives you the minus 1. In the second bracket, 3x minus 2x is x and plus 2 plus 3 gives you the 5. So we have got the two factors here, right? Okay, once again, the same formula I'm just showing you, a square minus b square. Just keep in your mind. And we have another formula, that is a minus b square is equal to a square minus 2ab plus b square. You know both the formulas, right? So let's combine both of them. When we combine, let's get one example. Look at this one. Okay, we have learned to use the a square minus b square. We have learned to use the taking common in all, taking common in group. Now here, before you start, you see, is there any common in all? Definitely not. If I try to common in a group, even that will not, it will not help you to factorize here. Okay, if I even try to form in a group first, and if I try to make a pair, I think it will not be useful. So what we do here, can we do something like that? So let's use the concept a square minus 2ab plus b square. That concept, we try to do that. So three terms has to be in a group form, right? So we can just do like this. See what I did here. I just took the last three terms in a one bracket, single bracket. See, my intention is just to make it like a compare with a square minus 2ab plus b square. That form, I'm trying to bring it here, right? So here, look at here, 49x square minus, now let's compare with a complete square. 4y square, I just make it 2y whole square. That's I consider as a square. So it means here 2y is a. Now 20y, you have to change 20y into the 2av form. So when you change 20y into 2av form, 2 is there, then a means 2y. Okay, in order to make it 20y, there should be the 5. So 2 times 2y times 5. So 2 to the 4, 4 5 is 20. So it will become in the form of 2ab. Now here we can clearly identify 2y is a and b means it's a 5. Now 25 can be converted into the 5 square. Now, if you compare with the a square minus 2ab plus b square, it is exactly in the same form. Can you see that? Okay. Now we can just make it 49x square minus, now you see here, 2y is a and 5 is a b. So it is in the form of a square minus 2ab plus b square, which is equal to a minus b whole square. So that is 2i minus 5 whole square. Okay. Now we can just make it 49x square as a 7x whole square. Okay, that will give you the 49x square. Why did I keep in that way? Because it is exactly in the form of a square minus b square, right? Here, can you see that? Okay, now here if I take this 7x inside the bracket as a and inside the bracket 2i minus 5 as a b, once again, this is in the form of a square minus b square, right? Now let's keep the formula here, a plus b. So 7x is a plus 2i minus 5 is a b. So that is a plus b from the first bracket. In the second bracket, 7x is the a minus 2i minus 5 as a b. That is in the a minus b form, right? And remember, whenever there's a minus, always keep the bracket. So now let's open the bracket. It will be 7x plus 2y minus 5. And in the second bracket, 7x minus is there. So 2y minus 5 becomes 2y plus 5.